Hello guys, welcome back to the course. In this video, I'm going to explain how AI speech-to-text system works. The process is consisted of 7 main steps. Okay, now let's get started with the first step, audio input. In this step, the user has two options. The first option is to upload an audio file. The file format can be MP3 or WAV. And the second option is to record his own voice. The goal is to provide speech for transcriptions. This is the starting point of the pipeline. The audio must contain clear speech to ensure accurate transcriptions downstream. Okay, now let's move on to the second step, audio pre-processing. In this step, the system is going to convert the audio to uniform format. Most of the times, audio files vary in sampling rate, bit depth, and channels. So AI will need to convert all inputs to a standardized format, for example, 16 kHz or 16-bit PCM, to maintain model compatibility and accuracy. And background noise like hums, clicks, or ambient chatter will be reduced using algorithm. The name of the algorithm is spectral subtractions, and this is to isolate the speaker's voice. And the system will also implement voice activity detection system. So this will detect regions of the audio that contain human speech and ignores silences or non-speech sounds. It will improve efficiency by focusing the model on relevant sections. Okay, now let's move on to the third step, feature extractions. In this step, the model is going to extract audio features, for example, MFCC. Let me explain more. So the audio will be transformed into a set of numeric features, commonly male frequency substral coefficients, or usually we call it MFCC, or log-mel spectrograms. And that represents how the audio sounds to the human ear. And we are also going to capture the sound pattern for the model. So these features summarize the pitch, tone, and timing of speech and are used by the AI model to distinguish phonemes or basic sounds units. Okay, now let's move on to the fourth step, acoustic model processing. In this step, the deep learning will map features to phonemes. It is going to use models like convolutional neural network, recurrent neural network, or transformers, and the system will identify which phoneme or sound unit each audio segment corresponds to. And the system is also going to be able to understand intonations and pronunciations. So the acoustic model also captures how the speaker says something, such as their tone or emphasis, allowing the system to better predict the words spoken. Let's move on to the fifth step, language model integrations. In this step, the model is going to gain contextual understanding via NLP or natural language processing. Let me explain more. Once the phonemes are predicted, a language model steps in to use grammar, syntax, and word probability to form coherent sentences. And the system is also going to predict and correct words. Even if the acoustic model mishears a sound, the language model will be able to correct it by understanding what the speaker most likely meant. So even if there was a typo in the text, don't worry, you will be fine because the system is going to correct it automatically. Okay, now let's move on to the next step, which is step 6, decode and transcribe. In this step, the model is going to perform phoneme to word decoding. Let me explain more. The phonemes are assembled into full words using decoding algorithms like beam search or CTC. CTC stands for Connectionist Temporal Classifications. And the system is going to generate probable text transcriptions. So the model will select the most likely transcriptions from all possibilities, aiming for the highest accuracy based on both sounds and language context. Okay, now let's move on to the next step, which is step 7, output transcribed text. In this step, the system is going to display the final transcript to the user, and this will be like the final result. And you can also do cross-check to make sure it is accurate and readable. Okay guys, I think that's it. That's all you need to know. I'll see you guys in the next video. Bye.